Hi everyone. Today I am giving a presentation on the topic stresses and strains. The content included in this presentation are introduction, load, stress, strain, types of stresses and strains, Young's modulus and shear modulus. Coming to introduction, commonly in engineering practice, the machine parts are subjected to various forces which may be due to either one or more of the following. They are energy transmitted due to weight of the machine, frictional resistances, inertia of reciprocating parts, change of temperature, and the result of different forces acting on a machine part is produces various types of stresses. Let us know one by one. Load. It is defined as any external force acting upon a machine part. Following four types of loads are important from the subject point of view. They are steady load, variable load, shock load, and impact load. Steady load is if a load acts on the body and it does not change in magnitude and direction, then it is called to be steady load. Variable load is also called as live load. A load is said to be a live or variable load when it changes continually. Shock loads. A load is said to be a shock load or suddenly applied load when it is applied suddenly or removed suddenly. Impact load. Coming to impact load. Impact load is when a load is applied with some initial velocity. Let's go to the next slide. Here we discuss about stress. Stress. What is the definition of stress? When some external system of forces or loads act on a body, the internal forces, which are equal and opposite, are set up at various sections of the body which resist the external forces. These internal forces acting per unit area at any section of the body is known as stress, and it is denoted by Greek letter sigma. Here is the formula for the stress. Sigma is equal to P by A, where P is load acting on the body and A is the cross-sectional area of the body. The SI unit of stress is Pascal. Note that 1 Pascal is equal to 1 Newton per meter square. In general, we use bigger units of stress, that is megapascal or gigapascal. 1 megapascal is equal to 1 Newton per millimeter square and 1 gigapascal is equal to 1 kilonewton per millimeter square. Coming to the next slide. Strain is defined as when a system of forces act on a body, it undergoes some deformation. This deformation per unit length is known as strain or unit strain. It is denoted by Greek letter epsilon, and mathematically it can be expressed as strain epsilon is equal to delta L divided by L, where delta L is the change in length of the body and L is the original length of the body. Strain is unitless. It doesn't have any units. Types of stresses and strains. There are actually three different types of stresses and strains. First one is tensile stress and strain. When a body is subjected to two equal and opposite axial poles, stress will be induced at any section of the body. This stress is known as tensile stress. Due to this tensile load, there will be a decrease in cross-sectional area and increase in length of the body. This ratio of increase in length to the original length is known as tensile strain. The tensile stress is expressed as sigma t and tensile strain by sigma epsilon t. Compressive stress and strain. It can be defined as the stress induced at any section of the body because of two equal and opposite axial pushes. Here you can see in the image that P is the load acting on both sides of the body, and at a section XX, sigma C is the compressive stress acting opposite to the load P. Due to this compressive load, there will be an increase in cross-sectional area and decrease in length of the body. This ratio of decrease in length to the original length is known as compressive strain, and compressive strain is given by epsilon c is equal to delta L by L, and compressive stress by sigma c is equal to P by A. Coming to shear stress and shear strain. When a body is subjected to two equal and opposite forces acting tangentially across the resisting section, the body tends to shear off the section. Then the stress induced is called the shear stress, and it is denoted by Greek letter tau. The corresponding strain is known as the shear strain, and it is the angular deformation caused by the shear stress. Shear strain is denoted by Greek letter phi. The formula for shear stress is tau is equal to tangential force divided by resisting area. This resisting area is different for two different cases. Case 1 is for single shearing of a riveted joint. As you can see in the previous slide, consider a body consisting of two plates connected by a rivet as shown in this figure. The tangential force P tends to shear off the rivet at one cross section. It may be noted that when a tangential force is resisted by one cross section of the rivet, then the rivets are said to be in single shear. And for this single shearing of a riveted joint, the area resisting the shear is A is equal to pi d square by 4. That is cross sectional area at the center of the rivet. this area is going to be shear off, and the shear stress on the rivet cross section tau is given by P by A, which finally results in 4P by pi d square. For in the case of double shearing of a riveted joint, case 2, the tangential force is resisted by two cross sections of the rivet. Two plates are connected by two cover plates as shown in the figure, and the tangential force tends to shear off the rivet at two cross sections of the rivet. So the shearing takes place at two cross sections of the rivet, hence it is called as double shearing, and the area resisting the shear is given by A is equal to 2 into pi by 4 into d square. Since there is two cross sections, it is multiplied, the area is multiplied by 2, and the shear stress on the rivet cross section tau is equal to P by A, which finally gives 2P by pi d square. So next topic is Young's modulus. As per Hooke's law, or according to Hooke's law, when a material is loaded within elastic limit, the stress is directly proportional to strain. That is, sigma is equal to E into epsilon, where E is the constant of proportionality known as Young's modulus or modulus of elasticity. The unit for Young's modulus is gigapascal in SI units, and mathematically we can write E is equal to sigma by epsilon, which is equal to P into L by A into delta L. Since stress is P by A and epsilon is delta L by L, finally we get E is equal to PL by A into delta L. Coming to the next slide, shear modulus. Shear modulus is expressed as G. Within the elastic limit, the shear stress is also directly proportional to shear strain. Mathematically, we can write as tau is directly proportional to phi, or tau is equal to G into phi. Therefore, we will get G is equal to tau divided by phi, where tau is shear stress, phi is shear strain, and G is equal to constant of proportionality, which is known as shear modulus or modulus of rigidity. It is also denoted by N or C, and the unit of shear modulus is gigapascal. Thank you. Please like and subscribe to watch more related topics.